Julkarnain bin Jainuddin. I'm Nagari Suresh from 2BEE S1/1 with my group members Yasagi Saundaraja, Muhammad Anik Akran, Muhammad Irfan Hajian Suashini, Muhammad Aidil, and Muhammad Shakir Haiman Muhammad Shah. Today we are going to present electronic system project assignment. Firstly, I'm going to present the part of about the introduction. An electronic system is a physical interconnection of components or parts that gather various amount of information together. Electronic systems tend to have both inputs and output, with the output being produced by processing the inputs. Electronic systems are generally represented schematically as a series of interconnected blocks and signals, with each block having its own set of inputs and outputs. This is figure 1. The figure 1 shows the electronic system block diagram. The system is designed part by part, at first which each of them are given their own specification. So in order to fulfill the requirement of each system, calculation based on the theory and formula has been made right before doing the simulation, so that it will be easier to design the circuit. And now I'm going to present oscillator 1. The calculation part. There are two different feedback loop. First, positive feedback loop, and second one is negative feedback loop. The positive feedback loop, given resonant frequency fr equal 1 kHz, assume C equal 1 nanofarad. Therefore, C1 equal C2 equal C equal 1 nanofarad. Then we find the value of R by using the formula and the given frequency. Fr equal 1 kHz equal 1 over 2 pi RC. R equal 1 over 2 pi FRC equal 1 over 2 pi times 1 kilo times 1 nano equal 159.15 k ohms. The nearest standard value is 159.2 kilo ohms. Then we recalculate the frequency with the calculated value of R and C to check whether it matches the specification. Fr equal 1 over 2 pi RC equal 1 over 2 pi 159.2 kilo times 1 nano equal 999.72 Hz. The nearest value is 1 kilohertz. For the negative feedback loop, use gain value to calculate RF and RA. AV equal 3. AV equal 1 plus RF over RA. 3 equal 1 plus RF over RA. 2 equal RF over RA. RF equal 2 times RA. Assume RA equal 10 kilo ohm. RF equal 2 times 10 kilo equal 20 kilo ohms. The nearest value is 20.1 kilo ohms. Then now we're going to see the multisim. This is the circuit we construct in multisim. This is the negative feedback loop, and this one is the positive feedback loops. Then now we run the multisim. Autoset. The waveform will form like this. Now we can see the measurement 4 Hz and the peak The peak value is 28.2 volt. And now we go back to the slide. The measured value is output frequency equal 994 Hz, and the peak amplitude VPK equal VPP over 2 equal 28.2 over 2 equal 14.1 volt. That's all from two. That's all from me. Thank you. I will use computer.
My name is Suhashini. Today I'm going to present about oscillator 2. There are two feedback loops. One is negative and one is positive. Okay, first positive feedback loop. Given resonant frequency Fr equals to 1 kHz, assume C equals to 1 nanofarad. Therefore, C1 is equals to C2 equals to C equals to 26.5 nanofarad. Then find the value of R by using the formula and the given frequency. Fr equals to 1 kHz equals to 1 2 pi RC. R equals to 1 over 2 pi FRC equals to 1 2 pi 20 kilo and then 26.5 nano. The answer is 300.29 ohms. The nearest standard value is 300.3 ohms. To ensure the answer is correct, recalculate the frequency with the calculated value of R and C to check whether it matches the specification. Fr equals to 1 over 2 pi RC. 1 over 2 pi 300.3 26.5 nano equals to 19999.5 Hz. The nearest value is 20 kHz. Okay, let's move to negative feedback loop. Use gain formula to calculate RF and RA. AV equals to 3. AV equals to 1 plus RF over RA. 3 equals to 1 plus RF over RA. 2 equals to RF over RA. RF equals to 2 RA. Assume that RA is equals to 10 kilo ohms. RF equals to 10 kilo. The answer is 20 kilo ohms. Then the nearest value is 20.1 kilo ohms. Okay. Now let's move to the multi-sim. This is the circuit. This is the negative feedback loop and this is the positive feedback loop. Okay. Now we have to measure. Set. Measure. This is the frequency. And then this is the peak to peak value. And then the output frequency is 17.0 kHz and peak amplitude VPK is VPP divided by 2. 7.98 divided by 2 is equals to 3.99 volt. That's all from me. Thank you.
Assalamualaikum and good afternoon. My name is Muhammad Syakir Aiman bin Muhammad Shah. My metric number is B0820104775. So for project assignment electronic system, I'm going to explain about summoning amplifier. For the summoning, we have to understand what is summoning first. So summoning is the another level type of operational amplifier circuit configuration that is used to combine the voltage present one or two more input into single output voltage. Inverting amplifier has a single input voltage V in applied to the input terminal. If we add more resistor to the input, each equal in the value to the original input resistor Rn. We end up with another operational amplifier circuit called summoning amplifier. For example, we construct this circuit. We use oscilloscope 1 and oscilloscope 2. So here is low pass filter. So here the result that we construct. So as you can see here, that voltage is decreased. So we're gonna check the measure value at 4.07. So oscillator 1 and oscillator 2 gonna connect into the pass filter here. So here the output. So output here we can measure here lah. We get the measure output voltage is 4.07, sorry, and the graph we get the sine wave. Okay, that's all for me. Thank you.
Hai, Assalamualaikum dan salam sejahtera. My name is Muhammad Anil Azlani. Today I will present about active low pass filter. So before I go through to this presentation, I want to explain a little bit about low pass filter. Low pass filter, uh, low pass filter is used to filter noise from a circuit. Noise is a high frequency signal when passed through a low pass filter. Most of the noise is removed and a clear sound is produced high. So as we know that have two type of pass filter, which is high pass filter and low pass filter. So the difference of two pass filter is a high pass filter attenuate content below a cut of frequency, allowing higher frequency to pass through the filter. Then a low pass filter attenuate content above a cut of frequency, allowing lower frequency to pass through the filter. So that is the little bit about theory about low pass filter. So this is Butterworth response value. So we use a second order generator right here. This is a second stage. So 2 minus R3 per R4. This is a formula. So it's fixed. And then we use second stage and we take this value 1.414. So 2 minus 1.414 equal to 0.586. So from there we assume that R4 is 1 kilo ohm, so we can see the circuit on what is seen. R4 is 1 kilo ohm, and then 0.586 times by R4, so we will get 586. 586 is a R3 value, because here we need to find the R3. And then given FC is 8 kHz, so 8 kHz ni from the question So this is a formula. So the capacitor is 10 nanofarad. So the capacitor here 10 nanofarad, and then we include the value inside the formula. Then it will be 1 per 2 pi times 8k. 8k is a frequency 8 kHz, and the C is a capacitor. This is 10 nanofarad. So we calculate on calculator, then we will get the answer, which is 1.989 kilo ohm. So it will be 2 kilo ohm because we run off the value. So 2 kilo ohm is a resistor, so we can see in the circuit 2 kilo ohm is R1 and R2. And then um, we go to the circuit. This is a low pass circuit that we construct in the multi-sim. So we open it the multi-sim. So from here, uh, you can see the graph. So this point is a critical frequency, which is when the frequency will be low. So that we can adjust the radio frequency because the equation we use 8 kilohertz. So from here you can see the when the frequency hit 8 kilohertz, so the frequency will decrease lah. Alright, that's only from me, Muhammad Anik Hassan. Thank you for listening.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan Najah. Today I will explain about full pitch rectifier. So this is the calculation value, theory and measure value. So the capacitor we use the 1 microfarad at the output of the rectifier as a filter. So this is the formula for VDC. So this is the V output and V ripple. So this is the measure value from the multi-sim. So this is the construct circle in multi-sim. So this is a circuit. This circuit full bridge rectifier. So as we use the AC voltage, full bridge, capacitor, resistor. So oscilloscope as the output. So I will run multi-sim. So this is the output. This is the from this as the VP. VP is yellow current. So value for the peak to peak VP is for 14 volt. So 40 volt divided to get the to 20 volt. So AC 20 volt for the peak. Yes. So the blue form is V ripple. V out ripple. So V out ripple we V to peak peak to peak is 7.96 voltage. So that is divided to get the 3.89 volt. So full bridge rectifier, the main is the smoothing capacitor to convert the full wave ripple output of the rectifier into the more smooth DC output voltage. So the blue plot on the waveform show the result of the using so 1 microfarad smoothing capacitor across the rectifier. So rectifier output. Previously the load voltage follow the rectifier output waveform down to 0 voltage. So here the 1 microfarad is capacitor is charged to the peak voltage of the output DC plus, but when it drops from its peak voltage back down to 0 voltage, so the capacitor cannot discharge discharge adequately to the RC time constant of the circuit. So, maintaining the voltage across the load resistor until the capacitor on, recharge once again uh, on the next positive slope of the DC plus. In other words, the capacitor only as a time to discharge briefly before the next DC plus. So recharge is back to the peak value. DC voltage applied to the load. Resistor drops only by small amounts. So, but we can improve the still by increasing the value of the smoothing capacitor as shown. So that's all for me to explain about the full bridge rectifier. Uh,
So I'm
Thank you.
Yoshiki. I'm going to explain about the voltage regulator and load part. So for calculation part, given output voltage V out equals to 5 volt and voltage regulator type is open shunt regulator circuit combined for the voltage regulator, and for load given load rated power is P out will be equals to 1 volt. So to get the R4 load rated power, we need to use the formula of power, which is P equals to V square over R. So P equals to 1 volt, V equals to 5 volt, and R4 is a 25 ohm. So the output voltage for R4 is the same with the output voltage for R2 with parallel with R3 since it's parallel. So we use the formula of the voltage divider for R2 parallel with R3 times by the 5 volt. So the R2 will be 2 ohm, R3 equals to 2 ohm, and VR equals to 5 volt. VR square VR2 is parallel with the R3 equals to 5 volt. So from here we know already zener diode voltage compare with the feedback voltage from R2 and O parallel with the R3. So there will be a slightly different value of the voltage Vz equals to 5.1 volt. Okay, so this is the parameters that we calculated and also measured for this circuit. So the voltage across the zener diode, the calculation will get 5.1 volt. Output voltage will equals to 5 volt. Load voltage will equals to 5 volt and power at load resistor will be 1 volt. So we will further with the multi-stream simulation part. Okay, this is the circuit that we constructed for the voltage regulator and load part. So this is the load of the for the circuit. So the voltage regulator we use the potentiometer, and this is a potentiometer to show the to adjust the voltage that we want. Okay then, so when I run, so this is the values that I obtained for the circuits. Okay, so from based on this thing, we know already the zener diode, the voltage. This is the multisim connected to the diode. The voltage I got is 4.805 volt. This is the one near the R3 and R2 which is parallel, so it will be the similar voltage. So 4.98 volt and some 4.898 volt, and this is the power. So the power will be 992.189 milliwatt. So this is the measured value I get. Now we'll go back to the slide. So the comparison between the calculated value and the measured value, they will slightly similar, a difference due to certain error conditions. So this is the table 2. Thank you.
Assalamualaikum warahmatullahi and hello everyone. My name is Muhammad Adil bin Maisa and uh, I will talk about the combination of all specification in this project. So as you can see here, for the first one, we have two identical circuit which is known as oscillator 1 and oscillator 2. And then this circuit will be combined together to produce one single output that will be forming to a summing circuit. So, the output for the summing circuit will be connected to the active low pass filter before it will be connected to the before it will be connected to the full bridge rectifier. And then the lastly, this output from the rectifier will be connected to the voltage regulator with the load. Okay, so for the discussion, for this project or for this assignment, we are using basic electronic system circuits such as wind bridge oscillator, summing amplifier, active low pass filter, full bridge rectifier, and also a voltage regulator with load. So for the oscillator 1 and oscillator 2, the wind bridge oscillator is one of the requirement that we use. So the wind bridge oscillator circuit are containing a low pass filter RC circuit and a high pass filter RC circuit. So for the low pass filter RC circuit, actually it will be enable only low pass frequency to pass through the filter. Meanwhile, for the high pass RC circuit, it only enable high pass frequency of the current to pass through the filter. Okay, so for the active low pass filter, it was good in requirement of the second order active low pass filter with 8 kHz resonant frequency with butterworth response characteristic. So for the second order active low pass filter, it is included of two pole with the same value of the resistor and the capacitor. Two or more resistor are added to the output of the filter by assuming that one resistor and calculating the other resistor using the damping factor formula butterworth response characteristic. So for the rectifier, we are using a full wave bridge rectifier that was designed for this rectifier of the circuit. And then a capacitor with 1 microfarad was added to the filter, the output of the rectifier. And lastly, for the voltage regulator with load, the voltage regulator is required to be built using OPM shunt regulator circuit. So the resulting difference voltage reduce the OPM output driving less, thus reducing its collector current or also known as a shunt current and increasing the collector voltage. So the original decrease in voltage is compensated by this increase keeping the output nearly constant. Okay, so for the conclusion, by constructing this circuit design for the project, we are capable of understanding the purpose of each block and then process involved during the simulation of this project or of the circuit. So the circuit design consists of two oscillators that will producing 1 kHz and 20 kHz output. Firstly, the low pass channel is oscillator dismiss higher frequency. Then signal enter the full wave rectifier which is will convert the AC voltage to the DC voltage. And lastly, the regulator or the voltage controller are used to generate fixed voltage which is 5 volt by adjusting RC attached. Lastly, simulation was successfully constructed by using multi-sim software. Okay, so I think that's all from me and my group, and thank you for listening to our presentation.